Okay, this is Module 5, Comparing Functions Practice. This is practice, basically, for the test. Jay and Keith want to know who can run faster. Jay even gave Keith a 4-meter head start. See, at seconds 0, Keith is 4 meters ahead. Okay. The graph below shows Jay's rate during the race and Keith's rate during the race. Calculate each runner's rate and include units for Jay and Keith. Okay, so we need rate. What we're talking about is rate of change, the rate at which they're running. Let's look at the information that we're given. It says here that if I read this point at 0 time, he's run 0 meters. At 1 second, he's run 6 meters. 2 seconds, he's run 12 meters. Okay, that's what this says. So his rate would be, when you're talking about a rate, time's usually on the bottom. So what we're looking at is we're looking at 6 meters per second. That's 2. So Jay is running at a rate of 6 meters per 1 second, right? If we look at this right here, that's what this point says. Rise over run, up 6 over 1. 6 meters per 1 second. Remember, our rate is always changing y over changing x, so that would be rise over run. How about this one? Our rate is changing y over changing x, okay? Because this is our x, which our first line is, and our y is the second line. Our change in y would be 9 minus 4. See, here's our y. And 9 corresponds to the 1. Our coordinates here is 1, 9. 1 minus 0. See how the 9 and 1 are together, the 4 and the 0? 9 minus 4 gives us 5. 5 minus 1 is 1. So that's 5. And that would be 5 what? What's the y? Y is on top. 5 meters per, what's on the bottom? X is your seconds. 5 meters per second. Okay? So Jay runs at a rate of 6 meters per second. Keith runs at a rate of 5 meters per second. Who's running faster rate? Jay, okay, because he's going 6 meters per second, where Keith's only going 5. Okay, we're not worried about C. Let's leave out C. D, how many meters would each runner be at after 10 seconds? Okay, so in this case, our linear equation, our y is equal to mx plus b. At time 0, he's starting at 0 meters. The rate at which he is running is 6, so our m is 6. Our equation for J is y is equal to 6x. Y is the total number of meters, because there's our y-axis, is equal to 6 meters per second times our x, which is number of seconds. Okay, so let's do J. If y is equal to 6x, and our seconds, our 10 seconds is our x, so we can tell that up here. Our x is seconds, x-axis is seconds. Our x's are in seconds, okay? So let's plug our 10 in. That would be y is equal to 6 times 10, which is 60, okay? So after 10 seconds, J would be at 60 meters into the race. How far would Keith be? Well, let's look and see. Keith's rate is 5 meters per second. Let's write the equation for Keith's running. Y is equal to mx plus b. Now, interestingly enough, he's getting to start 4 meters ahead, isn't he? Because our b is actually 4, where our x is 0, our b is 4, and they said he was starting 4 meters ahead. Okay, so we're going to replace the b with 4, and his rate is 5. Y is equal to 5x plus 4. So let's go down here, and let's fill this in. At 10 seconds, where is he going to be? Y is equal to 5 times 10 plus 4. 5 times 10 is 50, plus 4 is 54. After 10 seconds, he's going to be 54 meters into the race, right? If both runners began at the starting line, okay, so that means he's not 4 meters ahead, how long would it take for each to finish a 180-meter race. So if I got this one as y is equal to 6x, I got this one as y is equal to 5x, because he's starting at the starting line now, not 4 meters into it. Now, they said 180 meters, all right? Would that be my x or y? The meters is on your y-axis. Meters is on your y lineup. Meters would be y. We'd plug that in for our y. So in this case, 180 would be equal to 6 times x. Divide both sides by 6, and x would be 30. It would take 30 seconds for J to finish a 180-meter race. How about this one? Y is equal to 5x. Okay? Our number of meters goes in for y. 180 is equal to 5x. We divide both sides by 5. And x would give me, use your calculator, 180 divided by 5. And you would get 36. It would take Keith 36 minutes. That's if he started from time 0. Some of y'all did it with him starting 4 meters in. That would be 32 and a half. Just letting you know on that. Second problem, it takes Roger 6 hours to drive 48 miles. It takes Stacy 4 hours to drive 30 miles. Calculate each person's driving rate. Here's Roger. Here's Stacy. Roger, 6 hours to drive 48 miles. 48 miles. See, if we're talking a rate, the time's going to go on the bottom. 48 miles in 6 hours. Okay? To get to the rate, you divide 48 by 6 to get to your unit rate. 48 divided by 6 would give you 8. You'd be going 8 miles per hour. Pretty slow, right? Driving at 8 miles per hour. How about Stacy? Okay, let's see. She's going 30 miles in 4 hours. 30 miles, and so we put the time on the bottom, 4 hours. If you divide 30 by 4, 30 divided by 4, you get 7.5. Okay, so Stacy would be going 7.5 miles per hour. All right, 7.5 miles per hour. Roger's rate is 8 miles per hour. Stacy's rate is 7.5 miles per hour. Who drives at a faster rate? Roger does. He's going 8 miles per hour. Stacy's only going 7.5. How long will it take each driver to drive 72 miles? Well, where does miles go in, for the X or for the Y? If you set this up, guys, you know that your M is always changing Y over changing X. Your Y is your miles, right? Your X is your hours. So 72 miles, let's write our equations here. Here we would have y is equal to 8x plus b. B is 0 because he doesn't start with any miles. This is y is equal to 7.5x. Let's use our two equations. If Roger drives at 8 miles per hour, I'd put 72 in for the y, which is my miles. 72 is equal to 8x. I'd divide both sides by 8. X would be 9. So it would take him 9 hours to drive 72 miles. How about Stacy? She's going at a rate of 7.5 miles per hour. Okay? The miles is the y, so 72 is equal to 7.5 x. Divide both sides by 7.5. And x is equal to 72 divided by 7.5, which gives you 9.6. It would take Stacy 9.6 hours. That makes sense. It takes her longer because she's traveling at a slower speed. How long will it take each driver to drive 180 miles? Okay, our miles is our y. We've already shown you that. Changing y, miles is on the top. So we put 180 in for each. 180 is equal to 8x. For Stacy, it would be 180 is equal to 7.5x. In this case, divide both sides by 8, and x is equal to 180 divided by 8, which gives you 22 and a half hours. 22 and a half hours to drive 180 miles. Okay. In this case, you divide 180 by 7.5. And 180 divided by 7.5 would give you 24. That would be 24 hours. Okay, so it would take Stacy 24 hours. It would take Roger 22 and a half, which makes sense because Roger's driving a little faster. Okay, the third one. The graph represents the length of one candle as it burns over time. The table represents the length of a different candle as it burns over time. Well, as a candle burns, its height in inches decreases. So our slope here is going to be negative. It's going down. The height over time is going down. Same here. As time goes up, your height is going down, okay? So your slope here is negative. Calculate each candle's burning rate, all right? Well, let's see. Burning rate on this one. Our rate of change, our m, which is change in y over change in x. Rise over run. I've got 2 points here. Let's draw us a right triangle. Okay, I'm going down 1, 2, 3 inches. I'm going down 3 inches because this is inches. I'm going down 3 inches over what length of time? From here to here, that would be 30 minutes, right? Going down 3 inches in 30 minutes. If we do the math on that, negative 3 divided by 3, I'll get negative 1/10 inch per minute. Now let's do candle 2. M is equal to change in y over change in x. Here's my x, here's my y, because x comes first, y comes second. The change in x would be 12 minus 16 over 20 minus 0. See how the 12 and 20 go together? 16 and 0. 12 minus 16 is negative 4 over 20. If I do the division there, that would give me 2/10 of an inch per minute. So which one is burning at a faster rate? The candle 2, right? Because it's burning 2/10 of an inch per minute, whereas candle 1 is only burning at 1/10 of an inch per minute. Okay, and it's negative slope because the height of the candle is going down. How tall was each candle before it started burning? Well, at time 0, this candle was 10 inches long, right? So candle 1 is 10 inches. How about candle 2? At time 0, it was 16 inches. Candle 2 was 16 inches, okay? We're not going to worry about D. How long did it take for each candle to burn all the way? Well, at time 100 minutes, there's 0 inches left on candle 1. So that would be 100 minutes. When is this other candle at 0 inches? At time 80 minutes. Okay, you can read that directly off the graph, right? Okay. On station 4, the graph represents the Coleman's family road trip as they're traveling away from their home. The table represents the Hayden family road trip as they're traveling away from their home. Calculate each family's traveling rates. Okay, well, the rate. Your rate is m, which is change in y, over change in x. Here, let's look at this. We're going up 80 on your y-axis. And we're going over what? 2 on your x-axis. That is 80 what? Miles over 2 hours, 80 miles per 2 hours. If I divide that, that would be 40 miles per hour. So the Coleman family is averaging 40 miles per hour. How about the Hayden family? Again, our rate of change is change in y over change in x. The difference in my y values, 90 minus 45, and see how 90 corresponds to the 2? 2 minus 1. 90 minus 45 is 45, 2 minus 1 is 1, and this is miles per hour, so that is 45 miles per hour. Which family traveled at a faster rate? That would be the Hayden family. They're going 45 miles per hour. Coleman's are going 44. How far away from home will each family be after 13 hours? Okay, well, here our equation, y is equal to 40x plus 0, because they're starting at 0. This one's y is equal to 45x plus, and if you go back 45 at 0 times, you're at 0 minutes. Okay. How far away from home will each family be after 13 hours? Well, is the hours the x or the y? See, hours on the x-axis. Here, hours is on the x right there. So we've got y is equal to 40x, or 40 times the number of hours. That would be 13. And on the other one, we'd get y is equal to 45x, or y is equal to 45 times 13. 40 times 13 would give you 520 miles. 45 times 13 would give you 585 miles. Okay, so the Hayden family will have gone farther. How long will it take each family to travel 720 miles? Where would the miles go, the x or the y? Look, the miles are on the y-axis in both cases. So we need to plug this in for the y, 720 for the y. I've got my equation, y is equal to 40x. And we've got our equation, y is equal to 45x. Let's plug 720 in for the y. 720 is equal to 40 times x. Divide both sides by 40. And your x is 18. Okay, this one is 720 is equal to 45x. Divide both sides by 45. 720 divided by 45 will give you 16. X is 16. Okay, so the Coleman family would take them 18 hours because they're going 40 miles an hour. The Hayden family would take them 16 hours because they're going 45 miles per hour. Okay, we're not going to do 5 because it just deals with finding slow. 6. The graph represents Sandy's bank balance since January. Okay, the table represents Nikki's bank balance since January. Calculate each person's spending rate. Now, although this has gotten months like January, February, March, April, May, we're going to count how many months. Calculate each person's spending rate, including units. Okay, on Sandra, let's find 2 points that are on grid lines. Okay, there we go. She's going from 800 to 700, down 100 in what time frame? From January to February, 2 months. So she goes down $100 in 2 months. If I divide that, that means she's going down $50 each month, right? So that is Sandra's rate, down $50 each month. Okay, let's see about Nikki's. Nikki is going Remember, our rate would be change in y over change in x. 675 minus 700 over 1 month, right? So she is going down $25 each month. Her rate is that she's going down $25 per month. Who is spending money at a faster rate? Sandra, because she's going down $50 per month, where Nikki's going down $25 per month. Okay? If the pattern continued, when would Sandra have a balance of 0? Okay, well, let's think about this. Sandra's equation would be y is equal to negative 50x, right? We're talking about a balance of 0. That would be in money. Which one is money? That's your y, isn't it? It's on your y-axis. It's in your y. So I put in 0 for y on Sandra. Your Sandra's equation. Y is equal to negative 50x. 0 is equal to negative 50 times the number of months. I would divide both sides by okay, we need to make sure we've got the b in there. What did we start with on the b? Sandra starts with $800, so her equation is y is equal to negative 50x plus 800, okay? So her equation is y is equal to negative 50x plus 800. Okay, we plugged in our 0 for the y. We'd subtract 800 from each side. So negative 800 would be equal to negative 50x. Divide both sides by negative 50. This is Sandra. Okay. Negative 800 divided by negative 50 is negative 16. Okay, so it would be 16 months. It would take her 16 months to use all her money. If the pattern continued, when would Nikki have a balance of 0? Well, let's find Nikki's equation. Nikki's got negative $25 per month, but she starts with $700. So her equation is y is equal to negative 25x plus 700. Okay? So let's write her equation. Here's Nikki. Y is equal to negative 25x plus 700. Okay? So we're trying to get to a balance of 0. Negative 25x plus 700. I'd subtract 700 from both sides. That gives me negative 700 equals negative 25x. Divide both sides by negative 25. And x would be negative 700 divided by negative 25. Negative 28. I'm sorry, negative by negative is positive 28. So it would take her 28 months, right? If Nikki had deposited $100 into her account during the month of August and then continued to spend at the same constant rate starting in September, then when would she have a balance of 0? Well, that gives her another $100. She's going at $25 per. That's another 4 months. That would be 32 months, right? And then station 7. Audie and Danny are each starting their own bracelet making business. Audie charges $16 for 25 bracelets. That is $16 for 25 bracelets. Danny charges $24 for 30 bracelets. Calculate each person's earnings per bracelet, okay? So 16 divided by 25 would give us 64 cents per bracelet. For Audie. How about for Danny? 24 divided by 30. That gives me 80 cents per bracelet for Danny. Who is earning more money per bracelet? That would be Danny. How much money will each person make selling 80 bracelets? Okay, so for Audie, Y is equal to 64 cents per bracelet times your number of bracelets. And this is 80 bracelets, so 64 cents times 80. That would give you $51.20. And from Danny, it's 80 cents per bracelet times 80 bracelets. And that would be $64. How many bracelets does each person need to sell in order to make $100? Okay, if I need a total of $100, that would go in for my Y. 100 would equal to 64 cents per bracelet times your number of bracelets. I divide both sides by 64 cents per bracelet. And that would be 156 1/4 bracelets, which is 157 bracelets. You should have to round up if you're dealing with making at least $100. And then on Danny, we need 100 is equal to 80 cents per bracelet times the number of bracelets. So we divide both sides by 80 cents per bracelet. And you get 125 bracelets, okay? And then finally, find a better deal. You'll notice that both sides of these are exactly the same. They were designed to be cut apart, so sorry about that, guys. Answer the following questions to help Charlie. You've got cell phone companies, and Chit Chat charges 30 cents per minute, $15 monthly fee. Write the equation. The total she would pay would be equal to 30 cents per minute times your number of minutes plus 15. Stay Connected has no monthly fee, but you're paying 45 cents per minute, okay? Plus 0, right? If Charlie would like to spend $90 per month on her cell phone plan, how many minutes will he get from each plan? Well, if you want to spend $90, put 90 in for your Y. 90 is equal to, your total bill is equal to 30 cents per minute times the number of minutes plus 15. Okay? Let's solve for our X. Let's subtract 15 from each side. That would give me 75 is equal to 30 cents per minute times the number of minutes. Now let's divide both sides by the 30 cents per minute. And for X, you get 75 divided by 30 cents per minute. You get 250 minutes. Now let's try on this one. 90 is equal to 45 cents per minute, okay, times the number of minutes, and that's plus X, so that can go away. Let's divide both sides by 45 cents per minute. And X is equal to 90 divided by 0.45. And that would be 200 minutes. Well, which one would give you more minutes? The Chit Chat plan, okay? Which cell phone company should they pick and why? Chit Chat, because it would give you 50 more minutes. It would give you 50 more minutes of time than the other company.